Imagine you are standing on a beach. The tide is out, further than you have ever seen it. The wet sand stretches ahead of you for what looks like a mile. You assume it will come back. Tides always come back. But it does not come back. You watch the waterline retreat, and retreat, and retreat, until the familiar edge of the sea is just a distant shimmer. And then even that is gone. By morning, the ocean floor is exposed, not just the shallow shelf where swimmers drift and surfers carve, the real ocean floor, the ancient, crushing, lightless bottom of the world that no human eye has ever seen from above. A landscape so alien, it might as well be another planet. And it is happening everywhere at once. Every coastline on Earth, every harbor, every bay, every strait. The English Channel becoming a muddy plain you could walk across. The Mediterranean shrinking to a series of deep, landlocked pools. The Pacific, the largest body of water on the planet, pulling back to reveal a submerged world the size of a continent. This is not a storm surge in reverse. This is not a drought. This is the complete and total removal of all ocean water from the surface of the Earth. Approximately 1.335 billion cubic kilometers of water, simply gone. What follows would be unlike anything that has happened in the known history of life on this planet. Here is what the world would actually look like. The first thing you would notice, standing on that beach, is the smell. The exposed ocean floor is not sand and rock. It is billions of years of accumulated biological sediment, dead organisms, decaying matter, sulfur compounds, methane gas trapped in frozen hydrate crystals. As the water retreats and pressure is released, those methane hydrates begin to destabilize. Enormous plumes of gas bubble up through the newly exposed mud. The hydrogen sulfide released from deep sediment layers is toxic. The smell would be detectable hundreds of miles inland within hours. Scientists who have studied deep-sea sediment composition, including researchers at the Woods Hole Oceanographic Institution, have described the seafloor as a chemical system held in balance entirely by the weight and temperature of the water above it. Remove that water and the balance collapses. The seafloor begins to off-gas on a scale that has no modern equivalent. But the smell is the least of the problems. The atmosphere would begin to change almost immediately. Oceans are not just water. They are the primary regulator of Earth's climate system. They absorb approximately 30% of the carbon dioxide released into the atmosphere every year. They generate more than half of Earth's oxygen through phytoplankton. They drive the weather systems that distribute rainfall across the continents. They moderate temperature. Without them, all of those processes stop simultaneously. Within days of the oceans disappearing, the atmospheric consequences would begin to cascade. The jet streams that circle the planet and drive weather patterns are shaped largely by the temperature difference between tropical oceans and polar regions. Without oceans, those temperature gradients collapse. The jet streams destabilize. Weather systems that depend on oceanic moisture for their energy simply die. Within weeks, the majority of the world's rainfall stops. Researcher James Lovelock, whose Gaia hypothesis proposed that Earth functions as a self-regulating system, described the oceans as the planet's primary thermostat. Without them, he argued, surface temperatures would begin swinging to extremes that the land-based biosphere cannot absorb. The exposed ocean floor, which covers approximately 71% of the planet's surface, would heat rapidly under direct sunlight during the day and radiate heat back into space at night, creating temperature swings of extraordinary violence. The coastlines, which are now just the edges of a vast dry basin, would experience permanent howling winds. The exposed seafloor creates an enormous low-pressure differential as it heats. Air from the continental interiors rushes outward toward the basin. Dust storms, of a scale that makes the Dust Bowl look like a light breeze, would sweep across the newly exposed seafloor, carrying toxic sediment deep into continental interiors. Now look down. The ocean floor that is now exposed to the sky is not flat. It contains the longest mountain range on Earth. The mid-ocean ridge system stretches for 65,000 kilometers across the bottom of every major ocean, a volcanic spine that encircles the globe. It is taller in places than the Alps, and twice as long as all the continental mountain ranges combined. It contains the deepest point on Earth, the Challenger, deep in the Mariana Trench at approximately 11,000 meters below what was the surface of the Pacific, is now simply a very deep hole in the ground. Standing at its rim would be like standing at the top of a cliff, twice the height of Everest, looking down into darkness. It contains the flattest plain on Earth. The abyssal plains that cover much of the deep ocean floor are flatter than any surface found on land, laid down over millions of years by particles of sediment drifting slowly downward through the water column. And it contains something that would immediately become the most urgent problem facing every human being alive. The mid-ocean ridges are not dead geography. They are active volcanic systems. The reason they form ridges at all is that tectonic plates are constantly spreading apart along their lengths, and magma wells up to fill the gap. That process is currently happening beneath several kilometers of seawater, which provides the pressure and temperature regulation that keeps it stable. Remove the water and the pressure on those volcanic systems drops catastrophically. Volcanologists at the United States Geological Survey have studied the relationship between water pressure and volcanic activity extensively. Their research, and research from institutions including the Scripps Institution of Oceanography, consistently shows that reducing pressure on magma systems dramatically increases the likelihood of eruption. Remove 11 kilometers of water from the deepest ocean trenches, and you remove an enormous stabilizing weight from some of the most volcanically active geology on the planet. The mid-ocean ridge would erupt, not in isolated events, along its entire length, simultaneously. The scale of volcanic activity that would follow has no comparison in recorded human history. The closest analog scientists can point to is the Deccan Traps event, approximately 66 million years ago, when volcanic eruptions in what is now India released enough sulfur dioxide and carbon dioxide to fundamentally alter the planet's atmosphere and are now thought to have contributed to one of the 5 great mass extinctions. The eruptions along the exposed mid-ocean ridge would release volcanic gases into an atmosphere that is already destabilized, already losing rainfall, already heating at the surface. The sulfur dioxide would combine with what moisture remains in the atmosphere to form sulfuric acid droplets, acid rain on a continental scale. The ash clouds from eruptions across a 65,000-kilometer volcanic chain would begin to block sunlight within weeks. And here is the final problem. And it is the one that makes everything else irrelevant. Fresh water. All of the fresh water on Earth, every river, every lake, every aquifer, every glacier, every reservoir, depends ultimately on the water cycle. Rain falls on land because water evaporates from the ocean, rises into the atmosphere, condenses, and falls again. That cycle is powered entirely by oceanic evaporation. Without oceans, the water cycle stops. Rivers do not stop immediately. They drain from inland reserves and snowmelt and groundwater for weeks or months, depending on the system. The Amazon might run for months. Smaller rivers in arid regions fail within days, but eventually they all stop. Every river on Earth runs dry. Every reservoir empties. Every aquifer, cut off from the rainfall that recharges it, begins to drop and never recovers. The human body can survive approximately 3 days without water. There are 8 billion people on Earth. The time between the oceans disappearing and the effective end of human civilization on any meaningful scale is not centuries. It is not decades. It is measured in months at the outside and weeks in many parts of the world. The societies closest to the equator, already water-stressed, collapse first. Their rivers fail earliest. Their groundwater is thinnest. Within a month, hundreds of millions of people are without safe drinking water. The mass migration that follows would be unlike anything in recorded history. Populations moving inland toward the last functioning rivers. Populations moving toward higher latitudes where glacial melt provides a brief extension. Every conflict that has ever been fought over water in human history compressed into a single catastrophic moment, and all of it happening under a sky that is simultaneously losing its rainfall, filling with volcanic ash, and heating in ways it has not experienced for millions of years. The oceans took approximately 4 billion years to form. The earliest water on Earth arrived partly through volcanic outgassing from the planet's interior, partly through bombardment by water-bearing asteroids and comets in the early solar system. Oceans as we recognize them have existed for at least 3.8 billion years. Life itself evolved in them. Every living thing on Earth, from the bacteria in your gut to the forests on every continent, is descended from organisms that emerged from that water. Without the oceans, Earth does not become a desert planet. It becomes something worse. It becomes a geologically violent, atmospherically chaotic, volcanically active rock with rapidly depleting surface water and no mechanism to restore it. The beach you are standing on is now just the edge of a vast, exposed, toxic plain. The tide is not coming back. And the world that existed this morning, the one where every living thing on this planet was quietly dependent on 1.335 billion cubic kilometers of salt water, existed so seamlessly that almost nobody ever thought about it. Until now.